Hello, this is William from Visual Components. In this video, I'm going to show you how to manipulate the joints of a robot using our Python API. This will include the internal and external joints of a robot, as well as degree of freedom objects that are present in components. To get started, in the 3D world I have a layout open, which you can find a link to in the video description. So open that layout, select the robot here, and notice it's attached to a track or robot positioner, and the robot has a mounted tool. So if I go to the Program tab and use the jog command here to select the robot, we can see in the jog panel that the robot has 6 joints, and these 2 imported joints, so 1 joint from the track, 1 joint from the box gripper. So let's now use a Python script to get a handle for those joints and manipulate them in the 3D world. So go to the Modeling tab, and if you don't have access to the Modeling tab, you can use a Python add-on or a .NET API add-on to complete the rest of this tutorial. Let's now go to the Behaviors group here, and under Miscellaneous, add a Python script, and notice it opens the editor for me. And you first want to get a handle for the component, and I actually will make the text larger for you. So comp equals get component, and those joints in the robot are being assigned to a robot controller behavior. So let's say robot controller equals comp.findBehavior, and you can use this method if you know the name of the controller. So you can just type in controller here, and that's the name of that behavior in the component right now. And if I print it out and compile the code, you can see that it's a type of BC robot controller. Now another way to find this is to use that find behaviors by type method. So find behaviors by type, and just use the constant of VC underscore robot controller. Now this will return a list of all the behaviors in the component of that type, so we just want the first robot controller. Let me make the editor a bit bigger for you. There we go. Still a bit bigger. That should be fine. So if I compile the code, you'd see, yep, we get that robot controller. So if we go back to the Program tab, when you're using the jog command, that's actually what you're selecting in the robot. So if I click the robot, I'm actually selecting its robot controller, and the robot's executor is showing its program here in the Program Editor panel. So now, let's get a handle for the joints in the robot controller, and it's very easy. It's just a property of the robot controller behavior called joints. So if I print this out, compile the code, you can see it gives me a long list of joints. So let's actually get the length of that list. So let's use len. This is a built-in function in Python for returning the length of a list. So let's compile the code, and we get 8. So in the jog panel, we can see we have 6 joints here in the robot, and we're importing 2 external joints, 1 from the track and 1 from that mounted tool. Now let's actually get the internal joints in the robot. So let's loop through that joints list. So we'll say internal joints equals an empty list. We'll say for joint in robot controller dot joints, if the joint, if its external controller property is equal to none, then we'll add it to our list. So internal joints dot append joint. And let's actually print out that list. And what we expect is that the length of that list should be 6. So let's now compile the code, and yep, in the output panel we get 6. Now this property here called external controller, be very careful with it, because if you have an add-on that's controlling the robot, like an external controller, then just be aware of this. So you probably would need to use a different approach here. Let's now get a handle for the external joints in the robot. Now those external joints from the track and the mounted tool are actually being controlled by the robot controller in our robot, so those do have an external controller. So it's a behavior in a component that's driving the joints in another component. So let's get external joints equals an empty list. And we'll loop through again. So for joint in robot controller dot joints, if the joint external controller is not equal to none, that means it has an external controller, we'll add it to our list. So external joints dot append joint, and let's print out the length of that list. And what do we expect? We expect a length of 2. Compile the code, and yep, in the output panel we get 2. And let's actually print out that external controller behavior. let's say print joint.external controller. Let's compile the code. And you can see, yep, it's a VC robot controller object, which is the controller of these internal joints as well in our robot. What we can do now is let's create a method for getting the internal and external joints of a robot. So instead of doing these loops all the time, you can just create a helpful method. So define get internal joints in robot, and we're going to pass a robot controller. And instead of doing this loop here, we can get fancy and return a list using this built-in function in Python called list. Now we don't want the external joints, so we'll use the built-in function of filter. And this gets a function passed to it, so I'll use a lambda here to write a quick function to test if the X object has an external controller attribute equal to none. And we're testing with a list, and that list is coming from our robot controller. Now, it's a bit too long here, so I'm actually going to shrink my parameter here and just call it RC, but you can write it out longer to make more sense. We're just getting that robot controller joints. So let's actually just make our editor a bit bigger. There we go. And what do we expect? Well, we expect it to return 6 joints. So let's print that out to quickly test. So what is the length of the get internal joints in robot from our robot controller variable, which we got here? So it's a handle for this controller in the component. And we expect a length of 6. So let's compile the code. And it seems that we got an error. I know what I did. I actually put the parameter outside, that parentheses outside of here. So we don't need that, but we do need one at the end, because this filter function, this is its scope here, and then this outer parentheses, this is for our list function here. So let's actually clear our output panel, compile the code, and yep, we get a length of 6. Let's actually comment out this line of code here for printing the external controller. And let's do the same thing again, but this time for our external joints. So get external joints in robot. And that will pass the robot controller as an argument. And we'll return a list. We want to filter it out. And we'll use a lambda of x. And if that x object has an attribute called external controller that is not equal to none, then we know it's an external joint in the list we give it here. And make sure you have those 2 parentheses. Now, if you don't want to use a lambda here, you can define another function and just call it here if you wanted to. So you don't have to, use this lambda all the time. You can just write your own function and call it here. So now let's get the length of our list that's being given to us by this method. And we expect a length of 2. So I'll compile the code, and we get 2. There we go. Let's now get crazy and set the value of joints in the robot. So let's actually start with the internal joints first. So let's say for joint in get internal joints in robot, and pass it that robot controller. Let's print out the joint values first. So print joint dot current value. But let's actually first print out the type that this joint is. So I'll compile the code. And we can see that a joint assigned to the robot controller is a VC joint object. And this joint object has a property called current value. And if we print that out, compile our code, we can see we get 0, 90, and 0. So there probably is some repetitiveness here. And we can see in the jog panel that joint 3 in the robot has a value of 90, but all the others are at 0. So this is what the robot looks right now. Let's actually set the robot to be in a joint 0 position. So for that current value of each joint, let's set its value to equal 0. And if I compile the code, we actually need to render the 3D world when we set the joint values. So after we loop through, I'll use the method called getApplication. This will return an application object, but in this case I'll just chain the methods. So I'll call one function, then another function with that object to render the 3D world. I'll compile the code now, and yep, we can see the robot is now at its joint 0 position, and notice that the joints here are at 0 value. Let's now move the robot along the track, and also move its joint here for the gripper, or that tool. So in this case, we're going to use that method get external joints in robot. And instead of setting the current value to 0, let's set it to be Let's try 500. Now, you might not know what the max limit or the minimum limit of the joint is, so when you're writing a script, you may want to check that. But in this case, let's just use 500 and see what happens. So I'll compile the code, and we do get some updates in the 3D world. So now the robot is over here, and you can see this joint in the tool. It's obviously outside its limit, and you get feedback here in the jog panel as well. So we can fix everything just by resetting the simulation and return the robot to its initial joint state. And there we go. At this point in the video, I'm going to start talking about degree of freedom objects, also known as a DOF object. To give an example, let's minimize the script, go to the Modeling tab, and I have the robot selected in the 3D world, and you can see it has a root node, and if I expand this, you can see it has other nodes as well. So we have 1, 2, 3, 4, 5, 6, 7 nodes, but we have 8 if we include the root node. Now, most nodes in a component that are child nodes have a DOF object. So if I select axis 1 here, we can see in the link properties panel that the DOF object of this node defines its axis of movement. So it defines the joint type and the axis type. And the joint properties of that DOF object define how you move along that axis. Now in this case, our joint is assigned to a controller, so this controller is driving this joint. And to make that more clear, let's go back to our script and just quickly restore it. And in most cases, the root node of a component will not have a joint, so it'll just be, just stay there. So its DOF object will probably be none. So if we print it out, comp.dof, and this is a property for a component, but also a node, because a component object inherits this module called VC node. So if we now print this out, notice in the output panel we get none. But now, let's find this axis 1 node in the robot. So using the component object, I'll use a method called findNode, and I can find a node of this given name called axis 1, and let's print out the value of its DOF property. So I'll compile the code, and you can see it's a VC DOF object. So if you have access to the Python API reference guide, definitely check out that module there. And what we can do, we can now set the value of the joint that's for this DOF object, and you can do that with a property called value. Let's now set that to be 90, and we don't want to print that, but we do want to render the movement of the robot's joint in the 3D world. So get application.render, and what we expect to happen is that the first axis in this robot down here should rotate 90 degrees. So let's compile the code, and there we go. Let's go ahead and reset and go back to our script. So whenever you want to manipulate the joints of a robot, if they're internal joints, I would recommend that you use the DOF object. If they're external joints, you can just use the controller to get a handle for those joints and manipulate them directly. Let's now get all of the DOF objects for this component or the robot. So let's write a method to do that, because if I say print the component.children, this will return a list of nodes that are in the first element or the first level in this tree here. So you can see this axis 1 node here, it's in this first level, but all these other nodes are child nodes, so they probably won't print here for the root node. If I compile the code, we can see we get back a list of just one object, and it's that axis 1 node here. So we actually can get the first element in that list and print out the name of the node. And if I compile, we can see, yep, it's called axis 1. So we're going to have to use recursion and define a method for getting all those nodes in the component. Now, we probably don't want any child nodes in other components, for example, in the track or in this mounted tool here. So we have to make sure we account for that when we write our script. And let's do that now. So we don't want to print this, and we don't need to set the value anymore. And now let's define our method. And through the miracle of video editing, I don't want to bore you too much, go ahead and define this method here. So I'll walk you through it. It's called getAllNodesInComponent. So not the nodes in other components, but just this one component. So we have an argument for the component. We have a nodes list, which we set to be optional, but also empty. And then we're checking if there's not a node list that was passed by calling this method. We're creating that new list here. So it's a very similar approach that you might have seen in the other Python robotics videos. And then we have this other optional argument here called include root node. So this basically defines whether you want to include the root node of the component in your node list. So by default it's set to false. But if you do set that to be true, we're adding the root node of the component to our nodes list. And then for every node in the component or the node dot children, so it's returning that list of nodes, if the component of that node is equal to the component that we passed originally, then we'll append it to the list. Otherwise, we know that this node is from a different component, so we just want the nodes that are in that one component, not any attached components. And then if that node has children, we're then going to call the method again using that node and our list that we have here. So it's just going back and back and back, and then it returns that list. So let's actually print that out. So print the length of get all nodes in component. And we need to pass the component object that we defined here, or the component that's containing the script. And we won't use those optional arguments yet, but what do we expect to happen? Well, the length of this list should be 7, because in the component graph panel, this node tree here, we had 7 nodes here, not including the root node. So if we compile the code, we get 7. Great. Let's now see what happens when we give that optional argument of include root node a true value. What do we expect to happen? Well, it should add the root node to our list, and now the length should be 8. So let's compile the code, and yep, we can see 8 printed here in the output panel. So now that we have a handle for all the nodes that are in the component, we can now use this to get a handle for all those degree of freedom objects, which, remember, they define the axis or the mechanism of movement for the joint or the node, and then that joint has its own properties which you can access and control using the degree of freedom object. So let's now add a different method and define it here. And once again, with the miracle of video editing, I define this method here. It's called define get all DOF in component, and the first argument is taking a component object. And you could approach this in a couple different ways. You can first get a list using this map function, and what this will do, you provide a list, so get all nodes in component, and for every node in that component, I'm getting its degree of freedom attribute, so that DOF object. And that's what's being returned and assigned to this list here. And what you could do then, you could return that list, but in this case, remember the root node of the component will have a DOF object set to equal to none. So what I'm using now is that filter method you saw earlier to kind of filter out those elements in the list. So if it doesn't have an attribute of none, add it to my list and return it. So let's see how that works. Let's actually get rid of this here and print out get all DOF in component and give it that component object for our script. And if I compile the code, we can see we get a long list here. And if I scroll all the way to the right, you can see we don't have any none object there for the root node. So if I actually take this away here and say if it is equal to none, add it to the list, or we actually can just return the list. So let's say return list, compile the code, and we get the same output, but this time you can see we have that one extra element for none, which is coming from the component's root node. So we don't want that. So let's get rid of this, and I'm going to uncomment this line of code and set this back to not equal to none. So if the element from this list does have a degree of freedom object that is not equal to none, then return it as our list. Another way to do this, let's comment these out, is to return a list that you using the filter function here, and you're writing a function to check if that X object does not equal none, then it's going to be in the list. And notice that our list is coming from that map function. So map and get the degree of freedom object from all nodes in the component. And let's actually test this out now. Once again, so I'll compile the code, and we can see that, yep, so it doesn't give us that none attribute here, and we get the same length of the list that we got earlier. So there's a couple different ways you can get those degree of freedom objects in a component. And now that we have a handle for them, let's do something. So let's say for DOF in get all DOF in component, and we'll pass the component object for our script, and we'll set the value of the DOF object's joint to be 0. So we'll say DOF.value equals 0. And since we're updating the joints of the robot, let's do a render in the 3D world. So get application, and the application object will call that render method. So let's compile the code and minimize the script, and yep, the robot's at that 0 value. Let's go ahead and reset the simulation and clear our output panel. Now before I end the video, let's go back to our script and see what we did. So we first got a handle for the component containing our script. We then got a handle for the robot controller in this component, and we then got the internal joints and the external joints that are assigned to that robot controller. We then defined a method to get a list of the internal joints and a list of the external joints which we can call. And we then defined a method to get all the nodes that are in the component, not including the root node or including it. And notice this is not giving us the nodes of any other component that is attached to the robot, so not from the track, not from the gripper. And when you're defining the joint values or manipulating the joints of a robot, it's best to use the degree of freedom objects, which we're getting here with this method called getAllDOF_InComponent. And we then went through a loop of that list and set the value to be 0. Now remember, if you're using external joints, it's probably best just to use the robot controller and manipulate the joints directly. Alright, this concludes the video. If you have any questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.